execute 3 steps of Euler's method using h. That's the step size of 0.1. Our differential equation is this: dy over dx equals 4y plus 3x plus 2, and the initial value y at 0 equals 1. So basically this is the function fxy. We are trying to do the following. Okay, these x values and corresponding y values, those are the solutions. Y at 0, when x equals 0, y is 1. So at 0, y is 1. Now we are trying to approximate the solution at 0.1. If we go 0.1 to the right, we get here. So we want to find the solution, and 0.2 another solution at 0.2 and 0.3. Okay, in this way, and we are asked to do 3 steps. So here is the formula. So the next y point is equal to yn, means previous y point, plus h, that's the step size. So we are going by 0.1 times the slope. Okay, so dy over dx is the function, that's the slope at the previous point. So first we need to find the slope at the previous point. So we know the first point, very first point, 0, 1. So let's evaluate f at 0, 1. F at 0, 1. So plug in x equals 0, y equals 1. Okay, so 1, 0, so 4 plus 2, 6. Then take n equals 0 in this formula, we get y 1. That is in fact y at the next point, which is 0.1, is equal to yn, that's the previous y. Previous y value is 1. Okay, that's 1 here, plus step size 0.1 times the slope at previous point. So 0, 1, at 0, 1 the slope is 6. And now multiply 0.1 times 6.6, 1.6. So this is 1.6. So this is in fact 1.6. Now to find the next, that means y at 0.2, so we have to repeat this procedure. So let's evaluate this slope at new point. X is 0.1, y is 1.6. So let me go up, or let me find here the function value at 0.1 comma y is now 1.6. 4 times 1.6 plus 3 times 0.1 plus 2, and using calculator you're gonna get 8.7. Then now we can evaluate, we can approximate this value y2, which is in fact y at 0.2. Basically we are taking n equals 1 in this formula, then we get y2. So the previous y value, which is 1.6, plus step size 0.1 times slope at previous point, which is 8.7. Now use your calculator, multiply and add 1.6, you get 2.47. So this point was in fact 2.47. Next we have to do 3 steps. So y3 here, y at 0.3, which is y3. Now we need to evaluate this function, this slope at the previous point, which is 0.2 comma 2.47. So that's 4 times y, 2.47, plus 3 times 0.2 plus 2. Use your calculator, it's gonna be 12.48. Then y3, that's y at 0.3 in this case, is previous point 2.47, previous y value 2.47 plus step size 0.1 times the slope at the previous point, which is 12.48. Multiply and add 2.47, you get 3.718. So basically we did 3 steps, and we first found 1.6, then 2.47, then 3.718. Okay, now we want to do the same thing for the next question here. So the function fxy, which is the slope, dy over dx is the slope, is given by this formula, root xy plus 5y. Same thing here. Now let's evaluate the slope at the first point, 0, 1. X is 0, 1. So x is 0, y is 1, square root of 1 is 1. 0 times 1 is 0. Square root of 0 is 0 plus 5 times 1. So this is 5. Okay. Then using that formula you can go up and see y1, that is y at the next point 0, and we are going by 0.1. So 0.1 is previous y value, which is 1, plus step size times the slope at the previous point, which is 5. That becomes 1.5. Similarly, let's evaluate the slope at the previous point, means now 0.1 comma 1.5. X, y, plug in here, square root of xy plus 5y, you get 7.89 using your calculator. So y2, that basically y at 0.2 is previous point 1.5 plus step size 0.1 times previous slope at the previous point, 7.89, multiply and add 1.5, so you get 2.289. Okay, finally evaluate the slope for the third point to approximate the third solution at the third point. Evaluate the slope at 0.2 corresponding y 2.289. So you're going to plug in here x, y, then you get 12.12. So the final y3, which is in fact y at 0.3, that's previous y 2.289 plus slope, step size times slope 12.12. Okay, and use your calculator, it comes out to be 3.5. So y1, y2 and y3. So we can keep going, but MATLAB would do the work if you have to do a lot of steps.